Okay, Algebra 1 students, this is the second way that you can solve a quadratic equation by taking square roots. One thing that you can look for, as we saw in the other video, one thing that you can look for is no linear term, only a squared variable. Okay, a term with a squared variable. This is the other way that you can solve a quadratic equation by taking square roots. And that is if your variable is included in a squared binomial. Okay? So here we have a binomial squared, a square of a binomial. Here's a binomial, it's squared. Okay, so when you've got your variable inside this bit of business, you can also take the square root of both sides. And once again, as in the other video, it is possible that you may have one or two operations that you have to do in order to get the squared part all by itself. In this particular equation, you can see that I've got my square of a binomial, my squared binomial has another term. It's got a constant term, minus 1 right next to it, and then it is also being multiplied by the constant 3. So these are two operations I've got to undo in order to get that squared part alone. So I'm going to add 1 to both sides, undoing my negative 1, my minus 1. And you can see that gives me 26 plus 1 is 27. And then you also see that I am dividing both sides by 3. Okay, what that's going to get me is this binomial squared, okay, alone on one side of the equation. So instead of just a squared term like an x squared or n squared in our previous example, this is a square of a binomial, but it's all by itself. There are no operations happening to it right now. Okay? So the procedure is the same as with method 1. You're going to take the square root of both sides. Now the cool thing here is that when you take the square root of a squared binomial, what you are doing is you are undoing the square and getting rid of the parentheses, which means you can do operations on what you have left. It makes this process of solving so much easier. So you can see I did that. And here are our 3 little things to remember after we take the square root of both sides. Okay, remember to plus and minus your solutions. In this case, it's the square root of 9. We'll talk about that later. Simplify radicals if possible. Well, it just so happens that the square root of 9 is actually not an irrational number. It is a rational number. The square root of 9 is 3. But I still have to plus and minus it because I could have still squared the positive square root of 9 or the negative square root of 9 to have gotten this squared binomial. Okay? All right. So now that I've broken this binomial free of being squared, I can isolate my x and solve my problem. Okay? So you can see I've added a step here. Method 2 has an extra step. So once you plus and minus the rooted part, once you simplify the radicals, once you factor out an I, if necessary, in this case it's not, we're not trying to take the square root of -9, but +9, then you can move the constant to the other side to isolate the x, which is what you want when you solve. Okay? So in this case, 10 is being subtracted from x, and I am going to add 10 to both sides. You can see I've done that right here. So you would think you are done. And if 3 were underneath a root sign, you are done. Okay? Once you've simplified that radical. But when you have rational number solutions like this, you have to finish simplifying. So what you have to do is you have to take 10 and add it to 3. Okay, that's one of your solutions, which is 13. Or, well, not or, and you have to subtract 3 from 10 to account for the other solution. So 10 plus 3 equals 13, and 10 minus 3 equals 7. And if you put this equation up here in Desmos, you would see that it indeed crosses, whoops, sorry about that, it indeed crosses the x-axis when x is equal to 13 and x is equal to 7. So here's method 2. Thank you for listening, and I'll see you in the next video.